In this video, we'll be converting complex numbers from rectangular to polar form. Our steps for converting from rectangular form to polar form is to start by sketching a graph of the number x plus yi in the complex plane. We'll find r by using the fact that r equals the square root of x squared plus y squared, and then we'll find theta using the equation tangent of theta equals y over x, where x is not 0, and we'll choose the correct value of theta, right, because we're going to get 2 when we do our inverse tangent. We're going to choose the correct value based on the quadrant our graph ends up in. And then we just plug it into our r times CIS of theta formula. We'll start by graphing 4 times the square root of 3 plus 4i. We want to get a decimal approximation for 4 times the square root of 3 since we need to plot it. This is approximately 6.8. Just pop it in your calculator. So from our origin, we're going to go 6.8 to the right, and then 4 up. And there's the graph of our complex number. We need to find our r value. R is equal to the square root of x squared plus y squared. And again, we're basically just doing Pythagorean theorem on this triangle that has one side 4 square root of 3 and the other side 4. That'll give us our hypotenuse, the r value. So 4 square root of 3 squared plus 4 squared. Take the square root of that. That'll be the square root of. Here we'll square the 4 and the square root of 3. We get r to be the square root of 64, which is 8. That's a nice number. And then to find our theta, we're using the fact that tangent of theta is equal to y over x. So tangent of theta is going to be equal to 4 over 4 square root of 3, which simplifies to 1 over square root of 3, which we frequently see rationalized. Now, this happens when theta is equal to, now we need to be in the first quadrant because that's where our graph is in the first quadrant. So it happens when theta is equal to 30 degrees. And I think these are, tangent's one of the tougher ones to find it. We're doing a combination of 1/2 and square root of 3 over 2. Right, and there's that 1 over square root of 3 that we had before we rationalized it. So that means that our x value is square root of 3 over 2. Our y value is 1/2. And that happens when theta is 30 degrees. Now that we have our r and our theta, we just need to write it in our notation. We'll have 8 times the quantity cosine of 30 degrees plus I sine of 30 degrees. Or in our abbreviated notation, it'd be 8 CIS 30 degrees. Let's try another one. This time we want to convert negative 2i into polar form. Notice that we do not have a real part. This is the same as having 0 minus 2i. So graphing this from the origin, I'm going to go 0 in the real direction and then negative 2 in the imaginary direction. We'll find our r value. It's going to be the square root of 0 squared plus negative 2 squared. The square root of 4, which is 2. To find our theta, we'll use the fact that tangent of theta is equal to y over x. Y is negative 2, x is 0. So this is undefined. So when we're thinking for our theta, we're trying to think about when is tangent undefined. I think about its graph and where those original asymptotes are, and they're at pi over 2 and 3 pi over 2. A lot of times when we're graphing, we think negative pi over 2 and pi over 2, but since we want to be in positive angles, I'm going to do pi over 2 and 3 pi over 2. Well, looking at the position of my graph, it's not going to be pi over 2, that's 3 pi over 2, but we want to be in degrees. So that's 270 degrees. Now that we have our r and our theta, we just need to plug it into our form. This is 2 times the quantity cosine of 270 degrees plus I sine of 270 degrees. Or in our abbreviated form, 2 CIS of 270 degrees.